All right, so I'm going to go through all the questions that were given to you guys. Remember, just make sure you study these and you'll be fine for the test. So for question number 20, I'm starting on page 195 to 196. It says this distribution represents the length of time a patient spends in the hospital. Gives us this information. If a patient selected, find these probabilities. Find the probability that the patient spends 3 days or fewer in the hospital. So when we're looking at A, we need to look at 0, 1, or 2, 3 days. So that is this part here. So the odds of us picking a patient, or the number of patients that we have that spent 3 days or fewer, is 2. So out of all the people that we can pick, only 2 of them have stayed in the hospital for 3 or fewer days. Then we have to figure out, well, how many total patients are we looking at? So here we have 2 plus 15 is 17, plus 8 is 25, plus 6 is 31, and plus 9 is 40. So that means there are 40 total patients, 2 of which stayed 3 days or fewer. So that means we have an odds of picking 1 out of 20 of picking a patient that stayed 3 days or fewer. All right, for question B, it says the patient spends fewer than 8 days in the hospital. So that we can't include this 8 to 11 because it's fewer than 8 days. It's not including it. So that means we're looking at 0 to 3 days and 4 to 7. So that means first we need to figure out, well, how many total people stayed fewer than 8 days? And that says 2 and 15. So there's a total of 17 people who stayed fewer than 8 days. It's still 40 total people that we can choose from. So the odds of you picking, and this doesn't reduce, so the odds of you picking a patient that stayed fewer than 8 days in the hospital is 17 out of 40. All right, for C, the patient spends 16 or more days in the hospital. So that means we're only looking for 16 or more. We're not looking for anything less. So that's just this part right here. So there's 9 people that spent more than 16 days in the hospital, or 16 or more, and there's a total of 40. Once again, there's no common multiple here, so there's nothing we can reduce it by, so it's 9 out of 40. And then the last one for D, the patient spends a maximum of 11 days. So that's including 11. So that means we're including this 0 to 3, this 4 to 7, and now we're including the 8 to 11 because it's a maximum of 11 days. So 2 plus 15, as we already know, is 17, plus 8 is 25, so it's 25 out of 40. 5 goes into both of these, so it will be 5 out of 8 times, and that would be your final answer. All right, so this one says a recent study of 300 patients, so that tells us the total number of people that we have. So any probability that we're going to do, it's going to start with over 300 because that's the total number of patients that we have. It says they found that 100 alcoholic patients had 87 elevated cholesterol levels, and 200 non-alcoholic patients had 43 elevated cholesterol levels. If a patient selected at random, find the probability that the patient is the following. So what I would suggest you do for this is you create a table or a chart. So we can have alcoholic, and then we can have non-alcoholic, and then we can have elevated cholesterol, and then we can have non-elevated cholesterol, or just regular cholesterol, we'll call it. So there's 100 total people that are alcoholic patients. So I know that here I have 100. And it tells me that 87 of those 100 had elevated cholesterol levels. So that means 87 is here. Well, if I had 100 total, that means there's 13 left over for regular cholesterol or non-elevated. The reason why I'm telling you to put it like this is because all of these are pretty straightforward and generic, but if it said anything with the word or in here, then you would have to make sure that you're adding things together. And then in our non-alcoholic, it had 200. And we had 43 out of the 200 that had elevated cholesterol. So that means the people that had non-elevated cholesterol is 200 minus 43, which is then 157. Right? So then to go over this, we know for A, we know it's going to be over top of 300 to begin with. And it tells us an alcoholic with elevated cholesterol level. Well, here's our alcoholics. So what you can do in your test is you can highlight it. Remember, if it's the word or, you're going to be looking at things for a little bit differently. Then we can highlight the elevated cholesterol levels. So we look and see which one shares both. So in this case, it's just the 87. So it will then be 87 over top of 300. This reduces because 3 goes into 87. See, it goes into it 29 times. And 3 goes into 100, or 300 100 times. So it'll be 29 over 100. Right, for B, it says a non-alcoholic. Well, there's a total of 200 non-alcoholics, so we can then just do 200 over 300, which reduces to 2 over 3. And for C, it says a non-alcoholic with non-elevated cholesterol level, so that's this one here, and that will then be 157 over 300. I don't think they share anything, so I believe that is your final answer for that one. All right, so for this one, it says 2 dice are rolled by the probability of getting the following. So here for A, remember for this, you will need to produce this on your test. You will need to write the sample space of all of the possibilities when you're rolling 2 different dice. So I'm not going to provide this for you. You will need to write this out. It will count as a question, but you will need to write this one out. All right, so for this, a sum of 5, 6, or 7. Remember, the one thing I told you that's going to be nice and convenient once you write this is anything that you're trying to do will fall diagonally from each other. So we know that there's a total of 36 possibilities. So we're looking at 3 different kinds, when it's 5, 6, or 7. So I'm going to look for these individually, and since we have the word or, we're just going to go ahead and add them. So the possibility of getting a 5 is 1, 2, 3, 4. So there's 4 possibilities of getting a 5. The possibility of getting a 6, we have 1, 2, 3, 4, 5. So we have 5 possibilities of rolling a 6, and a possibility of rolling a 7 is 1, 2, 3, 4, 5, 6. So we have 6. So now we just add these up. So I'm sorry, this one I have no idea why I put 37. It should be 36. But when we add these up, this will then be 15 over 36. 3 goes into 15 5 times. 3 goes into 36 12 times. And that will be your final answer. All right. Then for letter B, we have doubles or a sum of 6 or 8. So that means we need to go ahead and find doubles. So that's out of 36. So that means when they're both the same, so we have 1, 2, 3, 4, 5, 6. So it's 6 out of 36. And or a sum of 6 or 8. So that means we need to look at a sum of 6, which we already did. So the sum of 6 we know is 5 out of 36. So we can already do 5 out of 36. And then we need to go ahead and find a sum of 8. So it's 1, 2, 3, 4, 5. So plus 5 over 36. But then for this one, we need to see, did anything occur twice? So I'm going to show you here we have, for the doubles, we have this line down here. So it's all of these. And then for a sum of 6, we'll do this. So for sum of 6, we have these here. And then for the green, for the sum of 8, we have these here. So we need to see, did anything occur twice? Because if it did, we need to subtract it out. So we had this 3 and 3 was part of the 6 and part of the double. So we know we need to at least subtract out one of the events that occurred twice. But we also had this 4 out of 4, which is part of the 8 and part of the double. So that means 2 events were counted twice. So we need to subtract them out. So this would then be 16 minus 2, so 14 over 36. And when we divide each one by 2, we will get 7 over 18. And that will be your final answer. Remember, when your events are not mutually exclusive, we need to subtract out the times where the event or the same thing happened twice. And since part of the doubles was also part of the 6 and part of the 8, we need to subtract both of those events out. All right, now for letter C, a sum greater than 8 or less than 3. So greater than 8, so these are all of our 8s here. So then if we want to do greater than 8, we just need to count all the ones below it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just count those again, make sure I did that right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's 10 out of 36. Or less than 3. So here's our less than 3. So there's one of them. So plus 1 out of 36. Nothing repeated or was shared between those two. They are mutually exclusive. So it's just 11 over 36. And our final one for D, based on the answers to parts A, B, and C, which is least likely to occur. So that means for these ones, we would have to go ahead and find the actual probability. So the decimal or percentage value. So this one is roughly 42% chance. This one is 39% chance. And this one is 31% chance. So our final answer for this one, the one that's least likely, is going to be letter C. There won't be anything like this on your test like letter D. It will only be A, B, or C. And the questions on this page, make sure you also know question number 23. It's something that we went over in class, something that I told you in class to make sure you also knew, because something like that could very well be on there. We went over that one the day before this. All right, so now for this one, remember, I will provide for you what a deck of cards looks like, since a lot of you guys didn't seem to play cards or know what was on them, so I will provide that for you. But remember, it's 52 cards, so the probability of finding a club, there are 4 different suits. Each suit has 13, so you have a probability of picking 13 different clubs out of 52 total cards. So it means you have a probability of picking 1 out of 4 picking a club. Right, the probability of getting a face card or a heart. So a face card, we have Jack, Queen, and King. They're all considered face cards, and we have 4 of each, so we have 12 of them. Or a heart. Well, a heart, we know we have 13 cards, because same thing as a club. There's 13 in a suit. But remember, anytime that it's not mutually exclusive, you got to subtract out the ones that are the same. So we have a Jack, Queen, and King of hearts. So there's 3 of them that we share, so we need to subtract them out because they appear in both the heart and the face cards. So that will then give me 22 over 52, which I'm going to write the answer here. That will then give me 11 over 26. All right, for letter C, I'll do that one here. A king and a spade. See, the key word here is an or. This one's an and, so they have to occur at the exact same time. Well, there's only 1 6 of spade in our deck of cards, so it's only 1 out of 52. The next one for letter D. A king, well, there's 4 kings, because there's 4 of each card. There's 52 total cards, so it's 1 out of 13, the odds of you drawing a king. And then the last one, the odds of you drawing a red card, well, there's 2 different colors. Each color is 26 cards, so it's 26 over 52, which will then reduce to 1/2, because there's 2 different colors. So it's one you could just jump straight to this if you really want to. All right, so this says, in a survey conducted at a local restaurant during breakfast hours, 20 people preferred orange juice, 16 grapefruit, and 9 preferred apple juice. If a person selected at random, find the probability that he or she will prefer grapefruit, that he or she prefers grapefruit juice. So first we'd figure out how many total people are we picking out of. So 20 plus 16 is 36, plus 9 is 45. And then we need to look at, well, how many people are part of the event that we want to take place. So grapefruit, so there's 16 people that preferred grapefruit. So we need to see, are there any common factors between these? Can these reduce? And that will be your final answer. All right, so same thing. This one, no, I'm sorry, I shouldn't have had this on there. It says, if a die is rolled, so that says 1, what is the odds of getting a 5? What are 6 possibilities? And there's only 1 5 on the dice, so it's 1 out of 6. Getting an odd number, well, an odd number, we have 1, 3, and 5, so there's 3 of them. There's 6 possibilities, so it's 1 out of 2. And then the last one, it's getting a number less than 3, so there's just 1 or 2, so there's 2 possibilities out of 6. So that means it's a 1 out of 3 chance. All right, so a recent survey indicated that in a town of 1,500 households, so that's the total number of people that we have, so we know that's the size of our sample. 850 had cordless telephones. If a household is selected at random, find the probability that it has a cordless telephone. So there's 850 people that have them, so it'll be 850 out of 1,500. We will divide 50 into each of these. So 50 will go into 800, so 2 into every 100, so 16, so it's 17 times. 50 goes into here 30 times. So then our final probability is 17 out of 30 of picking somebody with a cordless telephone. All right, so at a swimwear store, the managers found that 16 women bought white bathing suits, 4 bought red suits, 3 bought blue, 7 bought yellow. If a customer selected at random, find the probability that she bought a blue suit. So there's a total of, first we have to figure out how many women bought bathing suits, and it says 16, so we know it's out of 16. And then it says a blue suit. Well, we have 3 that bought blue, so it'll be 3 out of 16, and since that doesn't reduce, that's your final answer. For B, a yellow or a red suit, so first we have to figure out how many people bought a yellow, and then how many people bought a red. Well, we had 7 who bought yellow, and we had 4 who bought red, so we would add them together, so we have a probability of picking someone who has a yellow or a red suit 11 out of 16 times. A white or yellow or blue, so we would then need to add up 3 different events, or we could find the complement of red, because that's the only one that they didn't get. It doesn't matter which way you do it. But we had 3 blue, so blue was our third one. We had 7 yellow, and yellow was our second one, and we had no whites that they said. Oh, all right. I was trying to get through this really quick. Hold on. My apologies. Let me go back through these again. I would have redid the video, but I was already pretty far into it, so I just made a mistake. I didn't really read this right. 16 bought white bathing suits. So the total number of people that bought bathing suits are 16, 4, that's 20 plus 3 is 23, so 30. We have a total of 30 people who bought bathing suits. Blue, 3 people bought blue bathing suits, so it'll be 1 out of 10 chance of buying blue. For B, a yellow or a red suit. So yellow, it's out of 30 again. Not like I said before, 16. So yellow is 7. Red is 4, so it's 11 out of 30. We don't have anything common between them. All right, so for the next one, for white, yellow, or blue, that's everything but red. So I'm going to find the odds of finding a red bathing suit, so that's 4 out of 30. And then I'm going to find its complement. So it's 1 minus 4 out of 30. So this 1 will become 30 out of 30, so we can have common denominators. So we subtract 4 from that. So that means there are 26 possibilities besides a red. This will then reduce to 13 out of 15, and that means you have a 13 out of 15 chance of picking something other than red. And D, that's exactly what we just found with C. So D is exactly the same thing because there's only red, white, yellow, and blue. So not red and white or yellow or blue is the exact same thing. So that will also be 13 out of 15. All right, so if 2 dice are rolled, find the probability of getting a sum of a 5 or a 6. So there's 36 possibilities. So the odds of you getting a 5, here is our 5. So we have 1, 2, 3, 4. So we have 4 out of 36. Here's our 6s, 1, 2, 3, 4, 5. So it will be 5 out of 36. There's a total of 9 out of 36, which is then a 1 out of 4 chance. For B, a sum of greater than 9. So here are all of our 9s. So then we have 1, 2, 3, 4, 5, 6. So we have 6 out of 36 or a 1 out of 6 chance. Our next one is C. So we have a sum less than 4 or greater than 9. Well, here's our less than 4. So we have 1, 2, 3 of them. So it's 3 out of 36. And then greater than 9, we already did. So a sum greater than 9 is 6 out of 36. So that is then equal to 9 out of 36, which is also 1 out of 4, just like our A. Our next one, let me just erase this really quick. So our next one, for D, we have a sum that is divisible by 4. So divisible by 4, we have obviously 4, so there's 3 cases there, so 3 out of 36. See, 5 is not divisible by 4, 6 isn't, 7 isn't, 8 is, so we have 1, 2, 3, 4, 5. So plus 5 out of 36. 9 isn't, 10 isn't, 11 isn't, but 12 is, so then we have plus another 1 out of 36. And that is equal to a total of 8, 9 out of 36, which is 1 out of 4 as well. Our next one that we have is E, and that's a sum of 14. Well, we know that's possible to get a sum out, impossible to get a sum out of 14, so that is then 0. A sum that is less than 13, well, every single one is less than 13, so that means it is certain, which then means it is 1. The probability that a person owns a car is 0.8. That a person owns a boat is 0.3, and that a person owns both a car and a boat is 0.12. Find the probability that a person owns either a boat or a car. So we want to know that they own one or the other, or both. It could be either one. It could be that they just own a car, that they just own a boat, or that they own both, because that's what it means, either a boat or a car. They can also own both at the same time. All right, so that means we need to find out first, are these mutually exclusive? And they are not. So then the probability that the person owns a car is 0.8, plus the probability that the person owns a boat, which is 0.3. And then we need to subtract out the probability that they own both. Because all the people that own both are being counted for already with the boat and with the car. So we don't want to count the person twice because a person is only one person. So that is then 0.12. We would add these up. So this would then be 1.1 minus 0.12, which is then going to give me 0.98. Right, so that's the odds or probability that they own either a car or a boat. All right, so this is saying find the probability or there's a probability, a 0.39 probability that John will purchase a new car, 0.73 probability that Mary will purchase a new car, and a 0.36 probability that both will purchase a new car. Find the probability that neither will purchase a new car. So we want to know neither. So in this case, if you think about the last problem that we did, we found one or the other. So in this case, we want to find where neither of them have it. So we're first going to find out the probability that at least one of them has it. And then we're going to find its complement. So we will find a probability of John, which is then 0.39, plus the probability of Mary, which is 0.73, minus the probability of both, which is 0.36. So then we add these up. So this would then be 0.76. So that's the probability that at least one of them will buy a new car. So then what we need to do is, if we're finding the probability that neither, it's the complement of this. So it will then be 1 minus 0.76, and that is then equal to 0.24. That'll be your final answer. All right, now there will be, so it's important that you can think about, well, we want neither. So there's not enough information for us to solve for any other way. We need to go ahead and identify, well, if we can find out the probability of at least one of them getting the car, then to find neither's, we just need to find its complement. All right, that is it. If you have any questions, please send me them on Remind.